The Earth's deserts contain some of nature's last great mysteries. At Death Valley, the legendary sailing stones have fascinated and perplexed scientists for more than a century, until today.
I want you to meet Jim Norris. He's an engineer and an all-around really smart guy. Thanks for meeting me in the middle of nowhere, sir.
My pleasure. It's hard to get people to come this far out.
Now, we're at a place called the Racetrack. Give me a little more orientation. How big is this? What's it all about?
Racetrack is a dried up lake. It's a big flat surface, about 2.5, 3 miles long, a couple miles wide, shaped like a kidney, and it's so flat that the grade from one end to the other is just a couple of inches.
The racetrack rests in a dry lake bed, a geological formation known as a playa. Playas form when evaporation exceeds water flow in a depression that receives regular precipitation. The salty and brittle composition of the land becomes soft like clay when moisture is present.
Now, here on the racetrack, there has been a mystery for a long time. What has that mystery been?
Well, there's some stones out here that really didn't get the message. And these stones take off and wander around the surface of this playa. They don't sit still. And this is flat and level, and we're all wondering, why would they do that?
Jim and his cousin Richard Norris were the perfect pair of researchers to crack this mystery, with backgrounds in engineering and biology, respectively. Together, they head up the Slithering Stones Research Initiative, a think tank of brilliant minds dedicated to solving the conundrum of the racetrack.
What were some of the theories that people had before we figured this out?
Well, they really ranged. They ranged from the crazy to the probable. And the crazy were things like aliens, magnetism, tilting playas, vibrations on the playa. And we were pretty sure it wasn't those. The more likely ones were wind combined with rain, and some people were suggesting ice was involved.
Here's the big question. How do they move?
What happens to get these stones to be able to move is a series of very rare events come together. The first is we get a heavy rainfall in the wintertime out here. It's not unheard of, but it doesn't happen very often. And when we get that, we get a pool forms on this whole lake. Shallow pool, maybe an inch or two deep. Then winter nights are cold, and we get the surface of the pool freezes. There's a sheet of ice, and it's huge. It's many square miles of ice here. The next morning, almost every day out here is clear. The sun comes out, and it starts to thaw the ice. The ice starts to break up, and then the very common afternoon winds blow, and these great big sheets of ice start floating around on this very shallow pool. And if one of those floating pieces of ice runs into a rock, it will start pushing it slowly across the playa.
Yeah, and then you've got a wind. How strong is that wind?
Well, the ice is floating. That's always really important to understand. It's this ice that's afloat. It's like an iceberg. But the winds that are blowing it are only 5 or 8 miles an hour.
Fascinating.
It doesn't take much wind because these panels of ice are huge. And when they're that large, even a gentle wind will get them floating across the pool.
How fast do they go?
About as slow as baby crawling, a few inches a second.
And is that why, part of the reasons why that people could not figure it out, because it was happening so slowly?
That was exactly what the problem was. This is such a slow process that unless you're really focused on a specific stone and you have a way of telling that it's moving, and that's hard when it's 100 yards away from you. Unless you know that you're watching for something slow like this, you won't catch it. And we're sure that people were actually here when it happened before and just didn't realize that it was happening in front of them.
And how far can they go?
I think the longest track I've heard of that we found out here is 1,600 feet.
How big are these rocks?
Up to 700 pounds.
700 pounds, and they're moving that far?
Well, I'm not sure that they're moving, the big ones move that far. I think they move much less frequently, but there are certainly stones that are taking long rides out here.
And you thought this whole process to figure it out was going to take about 10 years?
We thought probably 10 or more. We were hoping it would take 10 or more camping trips.
And how long did it take?
2 years.
2 years to figure it out. You got to feel pretty good about that.
We got lucky.
Sometimes luck needs a helping hand. Along with the perfect timing, Jim and Richard's experiment succeeded thanks to a few delicately altered scientific instruments. rocks.
We wanted to have some rocks that we put out here that had GPSs in it. And we asked the Park Service if we could use stones that were known to move. And they're very protective of those stones. So they asked us to find rocks that were outside of the park that we would turn into our GPS stones. We located those about 20 miles away from here, set up our stones with the GPSs, brought them out here and hiked them out onto the playa, about 800 pounds of rocks.
That's when you know you got good friends. Right?
Indeed.
Hikers should avoid walking on the racetrack after rainy days. When wet, the surface on the playa becomes very soft and delicate. Footprints can scar the land for years.
I want to thank you for cracking the case. I also want to thank you for taking time to meet me out here today and explain this to everybody. Thank you so much, buddy.
John, it's been a pleasure.
With scientific wit and determination, the case has been closed on another of nature's mysteries. But somehow, the truth seems even more wondrous than any fantasy we could have ever imagined.
Nature's amazing, isn't it? I mean, it can really play tricks on us, but even though the mystery has been solved, you still have to come here and see this for yourself. It's that special.